All right, so today we're talking about permutations, and basically I need you to understand the difference between permutations and combinations. All right, so permutation, the order matters, and I'm going to be doing some permutation problems for you. I'll show you that formula in a minute. Combination, the order doesn't matter. Let's get what I'm talking about here. Let's say we have the letters A and B and C, and the order, if I take these three letters and I pull out two of them, say B and C. Let's say if I pull out B and C that the order doesn't matter. Then BC or CB would be the exact same thing. Do you get that if the order doesn't matter, it's okay to have them in either way, and it doesn't matter? Okay, that's called combinations. If the order matters, then of course CB is totally different than BC. They are different. All right, if I have these three letters, I want you to just think in terms of pulling out two of them, two at a time, and say, okay, if A, B, C, I could have A and C, that'd be one combination. But let's say that the order doesn't matter. Then CA is no different than AC. They're just one combination. I want you to answer for me. I'm going to actually change this to a four-letter combination. For a four-letter word, math. Four letters. How many three-letter combinations can you make with the word math? Like, for instance, A. Oh, I should have written it with different letters or different pens. Okay, so if I take math and I pull out three-letter combinations like AMT, that's one combo. Now again, if I don't care that the order matters, then AMT is the exact same thing as ATM or MAT. It does not matter. Okay, so take the word math, and I want to know how many combos you think there are of three of the four. Pull out any three. How many different sets could you make, do you think? Permutation would be how many sets of three could you make that have where the order matters, like ATH is totally different than AHT. So here's my question. How many different permutations are there? How many different combinations are there? And the way we usually write this is if I have four letters and I'm taking out three of them. Four, taking out three. I have four total, and I'm picking out three. P means order matters. I'll be saying it order patterns. Just keep pounding it into your head that it's hard to remember sometimes whether the permutation one is where order matters or the combination one is where order matters. But if I say order patterns, it'll force you to think order matters goes with P. Order patterns. All right. Take a guess. I know you may not be expert at this. It might take you too long to get exact, but about how many do you think there are for the P, and about how many do you think there are for the C, and then turn it my way so I can get a feeling for what you think. Take a guess. I don't expect you to have the right answer yet. Okay, thank you. Okay, thank you. Is that P's or C's? Okay, I need the C answer also. P answer and the C answer. All right, a lot of you are not getting this yet, which is okay. So let's talk about it. I can tell at least that you don't have any clue what I'm talking about yet. So P means the order matters. So let's make a list for the word math. If I'm taking out three-letter combos of all the permutations of that. All right, would you agree that ATH is one of the three-letter combos I could pull out? That's one of them, right? And if order matters, then there's a bunch more. HTA, THA, A, HT, there we go. Any more? I think there's more. HAT, TAH, oops. There we go. And that was just with the letters A, H, and T. What else could I have? Pick another three letters, like MAT. MAT is one of them. And if the order matters, do you get I'm going to have to do a whole bunch more? TAM, MTA. You see how many there are? There's lots. Some of these answers are huge later when we get into, like, you know, just 30 of us and rearranging us in order and stuff. It's just insane how many different orders there are. Okay, do you get that we're rearranging them because the order matters? What if the order didn't matter? Then if I put up ATH, then writing HTA would be irrelevant. ATH is good enough. It covers all 6 of those things. All these. So my point I was looking for when I looked at your answers was that you should have noticed that there were a lot more permutations than combinations, because in permutations, the order matters. And if the order matters, this answer is always going to be bigger. So your P answer is going to be big. And relatively, your C answers are going to be small. Because the order doesn't matter. So if you put out ATH, you don't have to put out HTA. Yes?
For the figuring out, like, the HGH, like that whole black.
Yep. Mm-hmm.
Could you just multiply that by 4 to get
the total number?
Yeah, because
I get what you're saying, because there's 4 letters.
for every one of those, you just take out one letter and do all the combinations without it.
That's a good way of thinking of that. I think that would actually work. All right. So I am, to be completely honest, I am not liking how I am telling this to you, because I started with too hard of a problem. So I'm going to go back and make it easier. All right. I am going to, I'm going to say apple, dog, and chicken. All right, I have the apple, the dog, and the chicken. If I pull out apple and dog, and if that's the exact same thing as dog and apple, if the order doesn't matter, am I doing a combination or a permutation? Combination. Okay. If I ask you to write down all the combinations, then, all the combinations of 2 things, how many 2-thing combinations could you have? I'd like you to actually write the list of all of them, because that other one would take forever. This one you can definitely do. And you can abbreviate them A, D, and C if you want to. Write down for me all the combinations, because again, order doesn't matter. There's more. All right. Tournament show. Let me see how many you think there are. Oh, maybe there is only 3. Okay. I think the people that have more than 3, thank you. Make sure that's silent. A and D. I think the people that had a big list, I think you were thinking permutations where the order matters. A and D, apple and dog, dog and chicken, and the only other combination is apple and chicken. There's 3. Do you get the difference between that and the kid who has a list of what did they do then? Permutation. Permutation is where all the order matters on them. All right. Which was it always a bigger answer? Permutations. Because the order matters, makes you have at least twice as many answers. As if you we're just going to say apple and dog, now you have to also say dog and apple. So when it's like permutation, the order matters, those are big answers. Okay, so now let's actually get into some problems here. Oh wait, I got to show you also how these are calculated. There's a formula right here. Now, if I want to take this one where I had the A, B, and the C, and I was going to pull out two-letter combinations, the way you would write that for a permutation is you start with a big P, and you say I have 3 letters to start with, and I'm going to pick out sets of 2. And that's if the order matters. Over here, I would say this is a C question because it's a combination question instead of a P for permutation. And I have 3 letters, and I'm going to pick out 2 of them. Get the difference there? It's just the letter of P versus the C. All right, so then how do you actually get the answers? Have you ever seen this button on the calculator, the exclamation mark button? It's not a button, but it's one of the functions that the calculator can do. And if you did, let's say, 6 exclamation mark, that means 6 factorial, which means 6 times 5 times 4 times 3 times 2 times 1. Did you know that? You're learning lots of things today then. Okay, so grab your graphing calculator. I'm going to show you where that factorial button is. Let's do 6 factorial, just for perspective to see if you're finding it right. Yes, you could just do it in your head. 6 times 5 is 30, times 4 is 120, times 3 is 360, times 2, which would be 720. Is that the right answer? Maybe you haven't actually tried it yet. Okay, so how do I put that in the calculator? 6 with the exclamation mark. You put in a 6, and then you hit the math button. Let me show you where it is. I'll clear this off. 6, and it's under math. And then, what kind of problems are we doing? Math problems? Well, yes, but PRB specifically. Do you see the PRB menu? You know what that stands for? Probability. Underneath the PRB menu, this is math and then PRB, and then you arrow down to the factorial right there. If you don't have a graphing calculator, borrow one of mine. I have 3 up here right now. You're going to want to know where this is. You're going to get tested on this, and you're going to have calcs for it. So if you haven't borrowed one of my graphing calcs, Miss V, for instance, Miss T, for instance, grab a graphing calc. You don't have a factorial button on your calculator. And it's you might say, well, I can go 6 times 5 times 4 times 3. Wait till it's 27 factorial. Then you won't be able to. Well, you could, but it'll take you forever. Gotta give me something. Thank you. There you go. Shoes would be fine. Large cash donation would work too. You can use other things, in the world. All right, so factorial, enter. Now I have 6 factorial, and I hit enter, and it just poof does 720. I showed you how you could do it in your head, but you can't. Well, you can, but they get to be huge after a while. If I'd have gone much farther, there was no way I was going to be able to do that in my head. Okay. Now, why do we need that? Because here's the factorial part of the formula. 3p2 would be, for instance, 3 factorial over 3 minus 2 factorial. So now, would I really need a calculator to do 3 factorial? No, it's 3 times 2 times 1, which is 6. I can do that. So this would equal 6 over, what's 3 minus 2? 1. What's 1 factorial? 1. So it's 6 over 1, which equals 6. And that's the right answer. There are 6 different ways to do that. Okay, how about this one? The C question. Generally, which one are the big ones? The P's or the C's? P's, they're like pigs. P, they're big. They're big pigs. Big P's. Okay? These are big answers, so this must be a smaller answer. How do you do a C? You do it like this. You go exact same formula, 3 factorial over 3 minus 2 factorial, but there's one more added feature that makes this answer smaller, and that is you include an extra one of these, factorial, 2 factorial. Well, that just means that it's the same exact answer, except there's a 2 underneath it. You divide by 2. So you'd have 6, which was the answer for this one, but there's this extra divided by 2 times 1, which is 2, extra divided by 2 in it. 6 divided by 2 is 3. Final answer to that one would be 3. There are 3 combinations, and there are 6 permutations when you had 3 letters and you were picking out sets of 2. All right, let me show you a few more examples on that one. In the classroom, let's say all of us were going in the parking lot and raced on the parking lot. Okay, and there's 30 of us. And I wrote this. Did the order matter or not? In a race, does order matter? Yes. It does. And then the 3 implies I picked 3 out of the group. Let's say it was first, second, and third place. That would be how you'd write the problem. And then if you had a calculator to do it, you would go 30 factorial over, what was the next part? 30 minus 3 factorial, which would be, what? 27 factorial. Now, do I really need the calculator to get these massive numbers, which they would be massive? No. Think about this. Do you get that this means 30 times 29 times 28 times 27 times blah, 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 blah? Over, this is 27 factorial. 27 times 26 times 25 times blah, 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 blah. It just keeps going forever. Do you get that from here over would cancel from here over? So it's really just 30 times 29 times 28. If you want to go get the gigantic number here and the gigantic number there, go ahead and divide them, but it'll be the exact same thing as if you had taken 30 times 29 times 28. So another way to think of this problem would be to use blanks and say, there are 3 places we're going to award. How many choices do I have that could be finishing in first place if there are 30 of us that are going to be running? 30. How many choices are there for second place? Well, we already had somebody get picked for first place. So now there's 29. You see where this is going? Now that we've already picked 2 different people out, how many choices do I have for third place? 28. There we go. That's the answer. 30 times 29 times 28. Now you might say to yourself, why couldn't I just do it that way? Well, today you can. A lot of your answers can just figure out with blanks today. But to be able to do this is the ultimate goal. So basically, I've taught you 2 or even 3 days of lessons all at once here. I know that felt probably hard and like there's a lot of things there, yes. But now you've got the big picture overview that we're trying to get you to get the difference between a permutation and a combination. That's where order matters or where order doesn't matter. And you now there's a formula now you know you can use and a factorial button on the calculator you can use to do these. But oftentimes they just boil down to having choices and you can do blank problems. Let's do something like that. Let's say we take a smaller group of you. Let's say I take who I think would be the top 7 fastest people. Okay, and I guess and I pick the top 7 fastest people. Okay, how many different combinations out of the 30 people in the room? How many different combinations would there be? Start with 30, and then is it a P or a C? C, because the order doesn't matter. I'm just going to pick these groups of 7 people. I'm not going to say you're the fastest, you're the second fastest, you're the third fastest. I'm just going to pick 7 people. That's why it's a 7. I'm picking out 7. Now, on this one, could you do blanks? You couldn't, because it's a combination. Permutation, you can do blanks. Yeah, and this one, it's not finishing in order, so I can't do the same thing with the 7 times 6, or 30 times 29 times 28, etc. So I have to use that formula I just taught you. 30 factorial over 30 minus the 7, which would be 23 factorial, and then one extra of these, 7 factorial. And if you put that all in your calculator, you could figure out the answer now. Go ahead, try it. It's really big numbers. Might want to write down what 30 factorial is so that you can come back to it later. And then 23 factorial. He's big. Thirty factorial is move the decimal over 32 spots. Holy smokes, you're going to really write that all the way down? So, exactly. If you just put in 30 factorial like this, oh wait, you got to put parentheses around it. Parentheses 30 factorial. Factorial, math, PRB, divided by another parentheses, 23 factorial, times, probably wouldn't need the times, but I'm going to do it anyway, 7 factorial. End parentheses. Enter. Whew, there's my answer. That's how many combinations I could pick of 7 of us. Isn't that insane? It's 2 million. It's 2 million different combinations of 7 people. I know these numbers don't seem possible, but they're right. It's exponential. It's like as soon as you go up from like 1 to 2 or 2 to 3, it just gets to be huge. All right, so on this problem, number 1, I would have used blanks. I would have said there was 26 choices for each of the letters, and then 10 choices for each of the numbers, and you multiply it all together, gives you your great big answer. What is the probability, now this is an important word here, that license plate has no repeated letters or numbers? All right, do you remember the probability is what you want over what's possible? I'm going to call it W over P. It's what you want over what's possible. We just figured out all the different license plates that are possible. It's that big beast of a thing. Did anybody actually figure out what it was? What was it? One, 7, 5, 7, 6. That seems too big. Is that it? That's it? Okay. All right. So there are 17,576,000, or is that 26? 76,000? Okay. All right. What I want is different. What I want is the ones that have no repeated letters or numbers. So I got to figure out how many are there that have no repeats. That's just like this, except the first blank is 26 choices for the first letter, but then I already used up a letter. So now I times it by what? 25. Times, now there's 24. Do you get why it's going down? Because I'm using up a letter. If I've already chosen a letter for the first thing in the alphabet, first thing on the license plate, then I can't have as many choices now because I already used one. All right, and then same with the numbers. Instead of 10, 10, 10, it's going to be 10 and then, come on, 9 and then 8. All right, so actually multiply this one out, and that goes on the top. And then probability is always a fraction. It's what you want over what's possible. And the ones I wanted, there was less of them. Because, you know, if they can't repeat things, there's going to be less. So somebody tell me, it wasn't 17 million anymore. Was it still a million at least? Or how many million? Can you read me the digits? 112320000. Okay. So it's 11 million license plates where there's no repeats. And there's 17 million total license plates. If I'm rounding, it's about 11/17, which is that more than half? So it's like 60, I don't know, percent chance. What exactly was it? 64? That means your probability is 64% that your license plate does not have repeated letters or numbers on it. Any of you know the license plate on one of your cars at home? Does it have any repeats? All right, so you're in the 40%. Does yours have any repeats that you? No. So how about you? Repeats? Repeats? No repeats? No. Yes, repeats? And it could also be that the ones that have repeats are easier to memorize. That could be part of the reasons that the people that raised their hand there was lots of people with remembering repeats, but technically it should be only a 64% chance that it has no repeats, therefore only a 36% chance that you'd have repeats on your license. And yet most of the ones that people remembered had repeats. Makes me think that repeats are easy to remember. All right, let's move on. Greg, Sam, and Tyler are the boys. The girls, Patty and Sarah. They're competing in a race. First, second, and third place is awarded. If you're in your homework right now, get out of it now and get to this example 2. So I'm going to ask you to turn yours in a second and show me what your answer is on this. How many different ways can the 5 racers place? Well, you can do it with blanks. How many choices are there for that first place spot? 5. And if you notice right away that you're just going to have a factorial answer, go ahead and write that. What's the shortcut way to write this answer? 5 factorial. Because it's really 5 times 4 times 3 times 2 times 1. Why can't it be 5 times 5 times 5 times 5 times 5? Because if some guy has already been chosen to finish his first place, he can't finish in second place also, right? You can't repeat people when you are doing a permutation because they can't be in 2 places at once. So if you said 5 factorial, that'd have been a good answer. All right, how many different ways can the 5 racers place if the girl needs to finish first and third? Ooh, definitely need to do this one with blanks. There's 5 places, put 5 blanks. Everybody, do this one and see if you can fight through what number should go here, 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 and here, and it is not 5 times 4 times 3 times 2 times 1. If a girl has to finish in first place, how many choices do you have for first place? That's what you're asking yourself. Turn it when you've got it. Close. Your first number's right. First number's right. Second number's not. First number's right. Second number's not. Everybody's starting with the first number. You're all getting the first number right. Oh, there's somebody who's doing it right. There's somebody who's doing it right. Nope, second number's too big, actually, because you can't have all 5 people in there. Nope, second number's too small. All right, here's what I'm going for on this. Do you get that there's only 2 girls, and therefore I have 2 choices here? But for the next place, didn't I already use up a person? There isn't 5 anymore. There's 4 that could go here. Do you get why that's a 4? A lot of people said 3 because I think you were assuming. Oh, wait a minute, though. Oh, you know what? You were actually thinking way smarter than I was thinking. You're right. You have to, even though it doesn't say that, why do you have to pick boys? Why do you have to only pick boys for this spot, even though it didn't say that? Yes?
Because a girl needs to finish first and third.
Yes, if a girl is going to finish first and third, and there's only 2 girls, then we really do only have 3 choices. I think some of you just assumed that, but you weren't thinking it through, and others of you actually were thinking it all the way through. And I'm sorry, I told you were wrong. It is a 3, because if this is a girl and this is a girl, then these other ones have to be boys because we've already used up all the girls. This one, by the way, was a 1. And I've already used up 3 people so far, so there's only 2 left. So this is the 2, and this is a 1. So 2, 3, 1, 2, 1 is the correct answer. Did anybody have that exactly right? All right, 6 of you, 7 of you did. Good job. All right, I'm going to do another one like that and see if you can hang with this. Let's say it's John, Paul, and Ringo. You know where they're from? The Beatles. All right. Let's say that John has to be first. Then how many different ways can you say their names? No, don't try to list them all in your head. Think blanks. First name, second name, third name. How many choices do you have for the first spot? Only 1. John has to be first. You know what I'm doing here? And then how many choices do you have for the second spot? 2, because there's 2 names left. And then the last one. So 2 and then 1. You always multiply your choices. This is something I'm going to keep saying over and over and over again, so listen to it. Whenever you have choices in these problems, you multiply your choices together. You never add 1 plus 2 plus 1. That wouldn't make any sense. You multiply them. Multiply your choices. So that comes out to 2. There'd only be 2 ways to do it if John has to be first. It's either John, Paul, and Ringo, or John, Ringo, and Paul. Okay. All right. How about this? Let's do your homework together. Wait, find the homework. It's right here. Get the first part of it done. Make it bigger, but not that big. Okay. An 8-volume set of reference books is kept on a shelf. There's 8 of them. Picture 8 books in a row like this. There's one book, here's another book, another book, another book. That's 4 of them. 5, 6, 7, and 8 books on a shelf. They got a little wiggly at the end there. Okay. How many ways can the 8 books be arranged on the shelf? That implies that the order matters. Because if the order doesn't matter, there'd be a weird answer. If the order doesn't matter, there's only one way you can put them on the shelf. You just put them on the shelf. If the order doesn't matter. So the combination answer is there's only one. The permutation is where you rearrange them. That's when the order matters, right? Permutation, order matters. This is a permutation question, so I could go, there's 8 books, P, how many am I going to put on the shelf? 8, 8P8. You could do that. That's what I taught you earlier, and you're going to really use more tomorrow. But what did I say about today's? You could pretty much use blanks in all of them for today. So let's do blanks. There's 8 spots. How many choices do you have for the first one? 8. How many for the second one? It's easier to understand this because they're actual books, and you can say, well, there's only 7 left. Now there's only 6 left, etc. And really, you could have put what for an answer? It's faster to write. 8 factorial. Good. How many ways can the books be arranged so that volume 5 will be the rightmost book? All right, I would make 8 blanks again. And let me make a smaller pen here. Let me make it black. 8, 1, 2, 3, 4, 5, 6, 7, 8 spots. And the volume 5 has to be the rightmost book. There's only one choice for this one. And then a lot of people are like, well, it's the same thing then. 8, 7, 6, 5, 4, 3, 2, 1. Nope, because you already picked the book. Now there's 7 for this one. Times 6, times 5, times 4, times 3, times 2, times 1, times 1? Yes. It's okay to have that. Uses the answers above to find the probability that volume 5 is the rightmost book if the books are arranged at random. So in other words, you randomly put out the books. And then what happens, what's the probability that you actually would get that last book to be the book 5, the volume 5? Well, then what you want, over what's possible, W over P. Of course, they're all like that. What you want is this answer. I don't know, whatever 7 factorial is. I don't know, some big number. I'd put 7 factorial. Over what's possible was what? All of them, which was what? 8 factorial. And if I were you, I'd just put that in the calculator. 7 factorial divided by 8 factorial. Since I showed you how to put it in the calc, otherwise you got to write these huge numbers and divide by another huge number. I would just type in 7 factorial divided by 8 factorial and see what the answer comes out to be. Wait, what? All right. See if you can do that right. Make sure that you know how to do that. All right, part D. How many ways can the books be arranged so that they are in the correct order with volume numbers increasing from left to right? Notice this is not a probability question. It says how many ways can you do this? How many ways can you do that? Only one. Now, if you wanted to prove it, it would be, let's not try to prove something that simple. How many ways can the books be arranged so that they are out of order? How many total ways are there? That really big number, right? 7 factorial, no, 8 factorial. Minus the one way where they're in order. What's the probability that the books happen to all be in the correct order? Like you would do it in the dark. You put the books on the shelf in the dark, you totally don't know what you're putting up there, and you turn on the light and they're in order. You'd be like, holy crap. It would be a really, really, really unlikely thing. In fact, it would be one way out of, that's what you want. How many ways are there? There's one way. Out of how many possible ways were there? Some really big number that you can figure out, and you'll get your answer. It's a really, really low probability. All right. Good enough. I think I want to give you the rest of the time to work on that. Not super easy. Unfortunately, the tests, a lot of people in my 4th hour class did not put their test number on their test, and therefore, like test A or test B, and therefore I can't tell which key to use, and I don't want to just randomly put them in there like I threatened I would, because a lot of people would get awful scores. So I'm going to go back and make them figure out whether they had A or B, grade them, and give them to you tomorrow. So I'm sorry. I'm blaming it on my 4th hour. Okay, that's all I got for you for today.